I think we'd never tell a story about anything in Boston Scientific without telling you what we do first and how important our patients are to us. So I just, maybe as an outline, I just want to spend a few minutes talking about Boston Scientific as a company, what we do, and then how that rolls into the three sites in Ireland, and then what we do in Cork. I want to show you an example of a product that we make and the impact that it has on patients and saving lives. And then we'll talk about our environmental policy as I protect our people, the planet, and all things Boston Scientific. And we'll show about how that translates into our carbon neutrality journey for scopes 1 and 2 by 2030, but also near net zero by 2050 as well. So we'll start off just by the introduction to Boston Scientific. So Boston Scientific is dedicated to transforming lives through innovative medical solutions that improve the health of patients around the world. So that's our mission statement. Our values. So our values are caring, meaningful innovation, high performance, global collaboration, diversity, and winning spirit. So, for the people who work in our company, we use those words and terminologies all the time. Boston Scientific globally. So we're headquartered in Marlborough in Massachusetts. 30 million patients each year benefit from the products that we make. I'll show you in a minute. About 22 million of those patients benefit from the products that are made directly at the Cork site across the road in Model Farm Road. $12 billion is the overall revenue of the company. So not the biggest company in the world. In the life sciences sector, companies of 50 billion and more in revenue could be more common. So 1 billion a year is reinvested annually in R&D. So when it comes to bringing new products, 90 new products launched in 2021, 18,000 patients. We've 17,000 products overall. We've 500 products alone in the Cork site. Those products come to us by innovation internally in our R&D divisions, but also by acquiring new technologies from startup companies that have spun off. In most cases, they spin off from university ventures. And when products become viable, a company like us will take on board those products. So just looking then at Boston Scientific in Ireland, we have the Cork site across the road, 1,700 people working there. In Clonmel, we have a similar size site. And in Galway, we have a much larger site of roughly 5,000 people working there. So over 7,000 people in Ireland overall. So our Galway site, we don't do the same products. Each of our sites will do different products. We all have a different mandate in terms of the range and complexity of products that are produced. We specialize in technologies as well per site. So Galway would be well known all down the years for the drug-eluting stents, aortic valves, and more recently they've added to their portfolio as well. In Clonmel has always been about cardiac rhythm management. So they make the defibrillators, the heart monitors, and the pacemakers. So that has been their stable of products for the last 20 years. But again, in the last couple of years, they've added more things like single-use scopes is a new product that they're bringing to the site. In Cork, we have 50 product families, very diverse. We do catheters for the vascular system. So from anywhere in the vascular and the organs such as the liver, kidneys, etc. We do catheters that go to the heart. We do catheters that go through the GI tract to the esophagus and the colon as well. A whole range of things. We do balloons for different applications there. I know this all won't make sense. That's why I'm going to focus on one product in particular. We also have some chemical products more recently. In the last 5 years, we've introduced some chemical technologies. We make hydrogels for different applications for embolizing blood vessels to tumors, for embolizing blood vessels to fibroids, and for delivering chemotherapy drugs right into organs. We've also, most recently, now we're working on a combined pharmaceutical product. So we have a medical device that delivers a pharmaceutical product, and it's the treatment for varicose veins. So there's just a wide variety of types of applications that we get involved in. So this is the Cork site. Just to focus on the right-hand side, so that's looking down at the campus, let's say from our side. And you see the white building on the left is the bulk of our manufacturing area. Right in the middle is a new building, which I'll mention when we get to the energy section. New 3-story building that rehouses our cafeteria area and our admin teams as well. You'll see over to the right, Munster Institute of Agriculture, built in the 1850s. That belongs to Boston Scientific. It's an integral part of our campus. It's a listed building, and we have a responsibility to maintain and conserve that building. But in doing that, we also use it for labs and office areas as well. And it's connected directly to our campus. You'll see in the background then the grey building is the Striker building. I think one of the lads you mentioned you had somebody, you had your mother working there. So again, our focus on patients, for us, it's all about the focus on patients. On the left-hand side, how do we do our priorities on a daily basis? It's about delivering for patients, delivering the product on time, on quality, and at the time it's needed. So imagine you've been fasting on a Sunday night, you're going into hospital for an important procedure on a Monday morning, and the medical team go to the cabinet and our product isn't there. That'll be quite a disaster for you. So we need to make sure our products are not only correct every time, but they're also there every time you need them. So quality, compliance, safety of patients, but safety of the people that work with us as well. And then serving customers, that's about delivery on time. Cost reduction, obviously, all companies need to be profitable to grow and to survive. But cost reduction has a different meaning as well in the life sciences sector. The cheaper we can make our products, the more available they become in jurisdictions right around the world. So, new products can be launched in jurisdictions at high price where health systems can afford it. But over time, we need to lean out those products, make them cheaper and cheaper so they can get to every corner of the world, to people who don't have as much money. So on the right-hand side, our mantra is 32 per minute. So from the Cork side, we do in 2024, we're going to do 22.5 million devices coming out of the Cork side across the road. When we divide that down by day, by week, by day, by hour, by minute, it's 32 per minute. So 32 patients every minute of every day receive some life-saving or life-improving treatment from a product that was made across the road. We're all very proud of that. And that's the kind of thing that gets us up in the morning and come to work. So again, just a little bit more about the range of products. The medical device world tends to break up into treatments in regions of the body. And there generally can be 7 or 8 different companies will see it different, but generally 7 or 8 divisions of that. So you've neuromodulation, deep brain stimulation. Some of our sites work in that. The Clonmel site does. That's not an area that we're in. The areas I've marked in purple are the ones that we play in. So peripheral interventions is areas in the vasculature, including some of the organs such as the liver and the kidneys, the pancreas, those sort of organs. Endoscopy is everything on the GI tract. So endoscopy down through the esophagus to the lungs, right down to the GI tract, and to the bile duct area, and down to the colon as well. Urology and pelvic health is all about things like the prostate, the urinary tract, and down there, right? Cardiac rhythm management, to mention our Clonmel site, are involved in pacemakers and defibrillators. That's the cardiac rhythm management in general. Electrophysiology is kind of a new enough field related to that, where we have devices for mapping the rhythms in the heart and creating nice 3D maps in real time, because that allows. So you might have heard of patients going for ablation, heart ablation to cure arrhythmia. that requires mapping of the heart rhythm so that they know exactly where to do the ablation. So we have the device where the surgeon can see that in real time and then be able to do the ablation at the right spot to get the best result. I won't talk about Watchman. It's a very specific item. Interventional cardiology then just focuses around the arteries around the heart. So the things that fail when you get heart attack, the things that get clogged with plaques and cholesterol. So we have devices that will get catheters in there to clear those blockages. Then you get the stents in there to keep those blockages open. And those are the kind of things that significantly improve people's life and people's survival rate as well. So the four purple boxes are the areas that the Cork site delivers products in. And as I said, we have 50 different product families, and that blows out into about 500 unique offerings. So I wanted to just focus for a little bit on one particular device. So Direction is a torqueable catheter. It's used, it can be, it's normally inserted to the femoral artery, and then it's used to thread its way up to, for example, to the liver or to the kidneys. And it could be doing that to get a device in there for biopsy, if we're getting chemotherapy drugs in there. It could be getting coils in there to embolize. There could be different applications. But the key thing about the catheter is how does it make its way through the tortuous anatomy of a person's body and turn these corners where you have to get from from a major vein or artery into a branch, and it can be complicated. So one particular use of this is to embolize blood flow. So massive hemorrhage in an aneurysm, let's say in a vein approaching the liver, for example, a patient can bleed out in a matter of hours. The Direction device can be used to get in there with coils that will go and block that bleed and save that person's life. So what I want to show you now, and I'm praying that the video works with the sound both online and in the room, but we got an email back in 2019. We got an email from a doctor late one Friday night, a very emotional email saying he had just saved a patient due to a product that came out of Cork. A couple of months later, he came to visit the site. He was a surgeon from London, and he wanted to meet the team that had made the device and explain to them how important it was. And we've captured that on video, so it'll give you a sense of what these products do for our patients.
Hello, my name is Dr. Kunal Khanna. I'm an interventional radiologist here in the UK, and I've been using Boston wires, catheters, stents, balloons, coils, you name it, for the past 10 years in my daily clinical practice. And the reason for that really is that you know when you ask for a Boston product that you're getting something of quality, and it's going to do what the team at Boston have told you it's going to do in any particular situation. This was a 52-year-old lady. She was at a family event with her whole family, which was actually celebrating her, I found out afterwards, and she suddenly collapsed and went what the family described as white. Myself and my colleague were there and had a look at this scan immediately when we got the call, and our first thought process was, it's over. There's nothing we're going to be able to do here. So for someone to be bleeding that much, they are literally hosing blood into their abdomen with nowhere to close that blood in or anything to do. But I looked a bit further and also noticed that, I should just say that there's an aneurysm there. So there's a blood vessel coming in here, and there's an aneurysm there, and that's what's popped and what's bleeding. And I saw a big group of people there, and I saw 3 young children, kind of being older than 7, who I assumed at that time were her children. Being completely honest with you as well, I looked at the patient, and she looked just like my mum. It was a very odd thing, but as I said, sometimes certain things as a doctor or even in our daily lives just get through that barrier that you put up to do your job. And that was just one of the moments for me. This is that superior mesenteric artery coming around. And although it looked like it was coming straight down and around, this is actually what was happening. It was coming out the back of the artery doing a turn like this and then coming back down. And every catheter that I tried to get in, I could just about engage into here. But with massive flow of blood coming down the main artery, it would just flick out every single time I tried to get into it with a wire. The timings were there. By the time we started, it was 5 o'clock on a Friday evening. And pretty much everyone in the room there wasn't supposed to be there at that time. They were there out of, the goodness of their heart. And I asked them if there was a direction catheter on the shelf. The nurse that we have at that time was only 6 months in. She didn't know what it was. She knew we'd ordered some time ago, but didn't know where it would be kept, and said, I don't think I've seen one. And it just so happened that our senior nurse, who'd been on some study leave, popped in to do some admin before the weekend. And she popped her head in, and I asked her, and she goes, yeah, I think we have one. And she pulled this out for me. And the absolute key to this whole story is this. That shape of this catheter might just be what I was looking for. And I pulled that wire back with a little bit of a sharp tug, and the direction just slipped into that position and was totally engaged in that position. It was hooked in. And yeah, I stopped for a minute because I was now talking about it. And the wire just followed down because I was engaged now, no problem at all. The anaesthetist said, what have you just done? And I said, I've just dropped the coils in. And he said, well, I'm not giving her any physiological support all of a sudden. I don't need to give her what we call inotropes, which are basically adrenaline, to keep the blood pressure up. He was like, the adrenaline's dropping off and the blood pressure's coming up. There were so many things that came together for this patient that meant she survived. Fate of where she ended up, a lot of luck in terms of timings and who was there. Was it my skill? It was one of my nurses who came and threw the direction box in my direction. Sorry, afterwards. And she goes, "There's your hero." I've always thought myself as part of a team of 5 or 6, but we're part of a huge team when you look at it. When I thought about it, who thought that there might be a case like this one day which needed a J-tip microcatheter? Who had the brains to think of that? Who worked out how to make it? Who designed it? Who produced it? Who made it? Who tested it? Who refined it and made it even better? Truly, in this situation, on this day, without any irony or any drama at all, that catheter was the only thing that was going to save that lady's life. And it happened to be put in my hands at the right time, so there's all that luck and fate involved, but still, the hero of that case is the catheter. It made me want to come here when I got the invite to say thank you, really, from that patient, but from me as well, and from everyone who's using the products that you guys are making. So, Mrs. K got to see her grandchild.
Excuse me. So that's why we go to work every day, knowing that we can have that sort of impact on patients. We have many of those stories, but that one was definitely the most impactful for us anyway. Okay, so on to more mundane matters. So Boston Scientific, again, we're probably, I suppose, as a major multinational, we're probably out in the leading pack when it comes to sustainability endeavors and commitments. So even as far back as 2017, our CEO made the commitment to carbon neutrality on scope 1 and 2 by 2030. So on that journey since then, and possibly before, I'll show in a minute. We've also now, under the science-based targets, committed to near net zero by 2050, based on 2019 as a baseline. Now that also includes, that's going to include scope 3. So scope 3 for us probably means different things to different people, but for us it means all our suppliers. We buy hundreds of different materials, wires, plastics, electronics, all sorts of materials go into our products. So we're committing to going back that supply chain and working with all those suppliers to to get carbon neutral all the way back down that line. That's the task of Scope 3, and for everybody, not just for us. So that's kind of like that piece there that put out is from our annual report. So that's Boston Scientific's commitment to carbon neutrality. How is that aligned then if we think about the climate action plan? So the Irish government's climate action plan, we're 100% aligned with that in terms of our 2030 goals. So we're looking at reducing our Scope 1 and 2 greenhouse gas emissions from our manufacturing and distribution sites by 2030. And 90%, I'll show you 90% is, I suppose it's going to be better than 90% even in our case. In some cases, sites might hold on to some contingent boiler capacity. And that's where some of the greenhouse gases might come in, or some of the other gas applications other than energy generation would lead to that other small 10%. So over the time, I'll show you our 3 sites have been working and with a lot of support from IDA and SCAI in terms of grant aid, but consulting aid, all of that stuff to design that carbon neutral journey. And as I'll go through it, it has been mostly about converting and decarbonising the heat loads. And with that comes our electrical infrastructure upgrades and all of that. So it's quite costly. For globally, we're spending about 150 million on our manufacturing network for that decarbonisation journey. For Ireland, I think it's about 30 million when you put the 3, maybe a little bit more. I probably shouldn't be disclosing those numbers, but that's only just the ballpark on it. So if you go back to Boston Scientific's version of energy management, we call it the C3, and our strategy around it has been cut energy use, convert to renewable, and then compensate for the rest. So I'll talk a bit about the cut first. I suppose the cut is, we've all been doing that for years. It's about having good energy management program, having good monitoring and targeting systems, projects like, energy efficient motors, LED lighting, awareness programs for all of our staff, all of those programs. That for us then by 2017, all our sites got accreditation to ISO 50001, which put a really good framework around our energy management program, giving you your significant energy users, your opportunities. There's a whole framework of how you drill down your energy reduction opportunities, and that all is about reducing your energy use over time. Then the middle bit, so once you've done, and we continue to do that, we'll always be continuing to do that, as I'll show again. But in the convert then, we're talking about converting to renewable energy. So I suppose one strategy, and the most popular strategy everybody's got at the moment, is converting all our heat loads to electricity. And then we get our electricity by renewable means. So that's the most predominant strategy. Obviously, other strategies are around using, let's say, hydrogen for your CHP or your boilers. That's a bit off in the future because mass production of green hydrogen is not quite at industrial scale. So electrification of heat plus the introduction of renewables. So back in I'm probably going on a slide now, but back in the earlier days, that was about signing up for renewable energies with the network providers, which was a virtual concept because the percentage of renewable energy in the Irish grid would have been 30% or less. I know it's growing and growing. The target by 2030 is to be at 80%. We know that in 2023, there were times where Ireland was at 80 and 100% renewable energy for certain short periods during the year. So we certainly have gone in that right direction. But we've been paying effectively a green tariff on our electricity to have that green cert renewable up to now. So, but we'll move on from there, right? Compensate then, actually compensate comes to the very end. When we get to the very end of this journey and we're down to maybe some small elements of greenhouse gas that we're not able to cut or convert, then we use compensation through the tariff, through the the emissions trading system. And that's where the compensate bit comes in. Now, Robin, every good energy management system needs needs good monitoring and targeting. So we're using the eSight system. It provides us with multiple reports. So if we're monitoring all our electrical loads, our heat and our water, our air systems, or chiller loads, then we can produce all this data, produce these dashboards that Robin actually did for us last year when he was with us. That's the kind of information that we use on a daily basis in terms of cutting. That's about being energy efficient, reducing waste, and looking for efficiency in projects. So just examples then of convert. So obviously the big decarb is coming in the future, but that doesn't stop us from doing small decarbs along the way. So in the new building that we just commissioned or finished at the end of 2022, for example, we converted the canteen to all electric appliances, so we've no natural gas to our kitchen. Small thing, but that's the opportunity that you take when you're making an investment. It costs a little bit more at the time, but it's part of the journey. We also installed about 30 kilowatts of solar panels on that roof. Again, a small enough solar PV offering, but it was part of that overall building construction. And that building, we received LEED Gold certification for that building just this year. So LEED is an American standard for efficiency, but it's very aligned to the BREEAM standard in Europe. We're an American multinational, so LEED is the standard that we operate to. So the standard obviously looks at sustainability from an energy management point of view, but goes right back to sustainability in the procurement of materials, sustainable sources of steel and concrete, in the construction, down to the efficiency of the construction period itself, and the materials used, the maximization of light, efficient energy controls, heating and lighting, and all of the above, and all of that feeds into your LEED certification. Now, the LEED certification then also brings in mobility. So the fact that we're on the Model Farm Road, we have bus routes nearby. We also have the TFI bikes outside. They all contribute to a workspace that is designed for sustainability, from traveling into it, traveling out of it, and working within it. So they'd be examples of how to convert all the time. You can take examples all the time. We have also, in more recent times, we've installed in our pharmaceutical plant, we've installed utility systems with a pure steam generator, which is electric driven generator rather than boiler and steam. So Ronan was involved in that one. We've got all the characters here tonight. So I've probably talked through this one a little bit already, but if we go back to our journey, that goes back to 2010, and this is really just scope 1 and 2 for the moment. So it's our natural gas or our greenhouse gases emitted on the site through boilers or CHP, and then it's the carbon impact of the electricity that we're importing from the grid. And that's what the difference between the grey and the black box are. But you see that if you go back to 2010, even though, and that's the combined 3 sites for Ireland. So even though all 3 sites have continued to grow in output and even in size over the last 3 years, we've significantly reduced to 2024. Our carbon emissions have kept reducing. So that started obviously with our energy projects, our ISO 50001, installing LED lights, efficient heating controls, all of that stuff that everybody's got to do. With CHP then, back in the 2000 and the 10s, CHP was one of the big modes of converting. So we have CHP plants installed in all 3 sites. So that was a significant reducer of carbon emissions. Now we're into the next phase. When we go to decarbonisation, we're going to retire the CHP because that's a greenhouse gas emitter on the site. So from 2024, so right now, our Clonmel site have already started to do their decarbonisation through heat pumps and chillers, which I'll show. Our Galway site will be doing it in the next couple of months. We'll be starting in 2020. So they're similar projects in each case. So that brings us all the way down. So that'll be our convert phase. We'll be converting by taking out the CHPs and moving to the heat pump strategy, upgrading our electrical networks. And right down at the end, we'll be at carbon removals. We'll be compensating for some very small portion at the end, where we might maintain contingency boilers for heat load. Again, this is the Cork version of that journey. So if you look at from going from left to right, you have our total kilowatt hours usage on electricity and gas. So our gas usage increased when we installed the CHP. Our electricity, all of our usages increased as we grew the site. We added more buildings, we added more production. But along the way, we've done projects. So we've the C2, the ACR stands for air change rates. So again, a very common energy project in pharmaceutical and med devices to, I suppose, sensibly reduce your air change rates. So clean rooms can normally be designed with air change rates of 30 per hour or 20 per hour for ISO 8. But we can challenge that down. We can bring it down to 16 or 15 or 12, depending on the applications. And that gives us, massive energy savings. In fact, in the Cork site, almost all our energy is in air conditioning. It's in the heat, the pumping or the fanning, whichever you put it, the cooling and the heating and the humidification, dehumidification. It's all about the air handling. So we have a project called the fresh air dehumidification. So again, that's just making the air handling more efficient in terms of only reconditioning the return air rather than reconditioning all the fresh air coming in. And there's some efficiencies in that too. It all depends on how your plant was designed first day, whether it was designed as a once through or whether it was designed to be efficient. So then you see coming to the 2025, so the red line is our CO2 emissions. We're up at around 3,000 kilotons of CO2 from the Cork site at the moment. And we track that very carefully on a monthly basis, and we try to manage that. So the heat pumps will be the next thing. That's going to crash the emissions to near zero. But at the same time, we will be doing solar PV on the roof. So this solar PV doesn't necessarily reduce the emissions any further. It just reduces the import from the grid and increases the renewable aspect of the electrical supply. So that's just a kind of a view of the journey. How are we going to do it? So at the moment, this is our energy balance, if you like. So we've gas and electricity coming in, gas to our CHP plant, electricity to our chillers. So the chillers are going in to condition the air, the hot water, which is heat recovery from the CHP, but also from our boilers. It's low pressure hot water. That's what's doing our air conditioning as well. But the environment, so we've heat dumped from the chillers, and we've heat dumped from the CHP plant, depending on the load profile at any given time of the year or the degree days. So that's what's going to the environment. The total primary energy, when you convert them both to primary energy, we're at nearly 30 million or 30 gigawatt. Yeah, 30 gigawatt hours. And our 3,000 kilotons is the impact, the carbon impact. So that's our current heat balance. That's how it works today. And this is still in design. We won't be doing this next year. We're still working on design on this. So when we say heat pumps, it's not really all about heat pumps. In this application, because of our heat load profile, because it's predominantly clean rooms more than any process applications, we're going to achieve it mostly actually through chillers with good heat recovery from the chillers. So you see the red line coming down from the chillers to give you water to water on your heat pumps to provide your heat. And The multi-pipe heat pumps then on that side is really used for top up. So when our environmental conditions are adverse, we may still need to top up that balanced system. And we'll use the cooling towers then. Again, the cooling towers are harvesting heat from the heat pumps and the feeding water to the cooling tower to the water to water chillers as well. So that's effectively taking gas, no gas on site. It's all electric power. So the electricity goes up, the gas 17,000 or 17 gigawatt hours of gas goes away. Electricity goes up to 13 gigawatt hours. The overall primary energy is reduced from 29 to 22 gigawatt hours. Not necessarily any big cost saving in that. The actual cost saving, it's fairly neutral overall for what you're giving. So the investment that the company is doing, like that project's going to cost us 7 to 9 million for the Cork site. There's no real cost saving on that. That's an environmental project for to achieve the net or zero by 2030. So that just it's infrastructure wise, it's quite an effort because we'll have to remove all our existing chillers or CHP or boilers, and we'll be installing a new utility building with all of that plant that I showed. So it's quite a significant project for us to do during 2025. And just I'm going to finish on this that we're also then looking into potential PPA agreement. Again, like many companies are doing this, but we wouldn't necessarily invest in these, but this will be a PPA. There's potential on our roof of our buildings to do about 800 kilowatts of solar PV, which, you know, on averaged over the output that we'll get for the year would today service about 10% of our load for the year. But once we grow our electric load with the heat pump technology, it'll actually about 5%. Again, nominal, but there is a saving in it, and there's an increased renewable aspect to that again. So just one other thing that, and I haven't the slide on it, but we are also working on, we have a global energy manager as well who's working on, we have invested in a solar plant in Spain, which actually combined output covers 90% of the 3 sites in Ireland. So that's again like a virtual PPA. We don't get electrons from Spain, but we have invested in that amount of solar energy in Spain. We are also working on some solar plants. You know, the solar farms in Cork are in Ireland are slow getting off the ground, but we expect in the next 2 years to have a site in Ireland which will fully cover the Irish sites. So we'll have effectively fully converted to electric, and we'll be fully renewable on that. But by then, the grid is going to be 80% renewable anyway. So all our we'll achieve that overall for scope 1 and scope 2.